recipe. This is team id 8 and this is my program. Here first I am importing all the libraries which are needed, and here we are loading the label train data set, and then here we are tokenizing the data and making the sequences, and here we are padding the sequences into the same length, and here pre means we are doing the padding before the each sequence, and here we are splitting the data into test and train data, and here we are defining the sequential model, and after that we are adding the embedding layer and then adding the LSTM layer, and here we use the activation sigmoid, and then we are doing the compilation here and then fitting here, and this is the callbacks list, and here we are calling the callbacks of tensor board for the visualization in the tensor board. And I have already executed this one, and this is my tensor board visualization, and this is the accuracy, and here accuracy is increasing and the loss is decreasing here, and validation accuracy increasing in the beginning and slightly reducing afterwards, and then here how it changes when we change the models and layers. First, with simple RNN and words in the embedding layer as 8 and no dropout layer, we got the test accuracy as 0.9447 and validation accuracy as 0.8140, and when we changed the simple RNN to simple LSTM, we got the better model, because standard RNNs suffer from vanishing and exploding gradient problems, whereas LSTMs are the type of the RNN which uses special units, and these are called the memory cells. Here it can store data for long periods of time, so we are getting the best accuracy here. Now we are changing the number of these words, so nothing but output dimension of this one, and number of words is the input dimension, and this is the input length, which are the parameters of the embedding layer. And now when we increase the output dimension to the 16 and without dropout layer, here we got the accuracy 0.8652, which is the better than the previous one, which means that when we are using more output dimension, we are getting the better result of accuracy. And word embedding is nothing but is the family of natural language processing techniques aiming at the mapping semantic meaning into a geometric space, and this is done by associating a numeric vector to every word in the dictionary such that the distance between two vectors would capture the part of semantic relationship between the words, and geometric space formed by these vectors is called the embedding space. And here now we are adding the dropout layer. When we add the dropout layer, our accuracy is little decreased, and this is because dropout is a technique where randomly selected neurons are ignored during the training. They are dropped out randomly, and if they are dropped out randomly, uh, if they are dropped out randomly from the network during the training, then the other neurons have to take over the data which are represented by the dropped out neurons, and then the network becomes less sensitive to the specific weights of these neurons. uh, that's why we're getting good accuracy. Sorry, uh, that's why the accuracy is decreased. Thank you.